Dr. Elena Vasquez had seen paradigms shift before, but never like this. Standing in her lab at the Institute for Advanced Physics, she watched her life's work crumble in real time on the holographic displays surrounding her. The elegant equations she'd spent 15 years developing were being systematically dismantled by an algorithm that had been running for exactly 43 minutes. "Ma'am?" Her research assistant Marcus approached cautiously. At 22, he belonged to a generation that had grown up expecting scientific revolutions every semester. "The quantum resonance data is coming in from Geneva." Elena didn't look away from the display. The numbers cascading down the screen told a story that would rewrite physics textbooks worldwide. Again, this was the 7th major paradigm shift in her field in the past 18 months. "How bad is it?" she asked, though she already knew. "Complete theoretical restructuring required," Marcus replied, his voice carrying the practiced neutrality of someone who had delivered this news too many times before. Elena finally turned from the display, her dark hair showing premature streaks of gray that hadn't been there 2 years ago. The acceleration was taking its toll on everyone in the scientific community. Careers that had once spanned decades now condensed into months of relevance before being swept away by the next breakthrough. "Show me," she said. The hologram shifted, displaying the results from the Large Hadron Collider's newest configuration, but this wasn't the LHC she had known as a graduate student. That machine had been upgraded, rebuilt, and fundamentally redesigned so many times that calling it the same instrument was purely ceremonial. The current iteration, LHC-7, operated on principles that hadn't existed when the original was conceived. "They've confirmed the existence of temporal quantum states," Marcus continued, his fingers dancing across the control interface. "Not just theoretical anymore. They're stable, reproducible, and," he paused, swallowing hard, "they're controllable." Elena felt her stomach drop. Temporal quantum states weren't just another discovery. They were the key to manipulating the flow of time itself at the subatomic level. If the results were verified, it would revolutionize not just physics, but the very nature of scientific research itself. "Who else knows?" she asked. "The paper hit the preprint server 17 minutes ago. Dr. Yuki Tanaka in Tokyo has already published a theoretical framework for practical applications. There's a team in São Paulo claiming they can build a prototype within the week. And," he hesitated. "And 3 separate AI systems have independently derived the same conclusions and are proposing extensions to the theory that none of the human researchers have thought of yet." Elena sank into her chair. The artificial intelligence systems hadn't just matched human scientific capability, they had begun to exceed it. What's more, they were accelerating their own development, creating a feedback loop that was pushing scientific discovery beyond human comprehension. Her secure communication device chimed. The director wanted to see her immediately. Dr. Rebecca Sterling had been running the Institute for Advanced Physics for 3 years, which in the current climate made her practically ancient in terms of administrative longevity. Most department heads burned out within 18 months, unable to keep pace with the constant reorganizations required by accelerating discovery. "Elena," Dr. Sterling said as she entered the office, "I assume you've seen the Geneva results?" "Just now, Rebecca. If this is verified, it's already been verified. Tokyo, São Paulo, and CERN itself have all reproduced the results. We're looking at a fundamental shift in our understanding of temporal mechanics." Sterling gestured to the wall display, which showed a global map dotted with research institutions. Every major lab is scrambling to adapt their research programs. The National Science Foundation is holding an emergency session tomorrow to discuss funding reallocation. Elena sat down heavily. "How many times is this now?" "This year, I mean. 17 major paradigm shifts across all scientific disciplines. Mathematics had 4 restructurings in the last 6 months alone. Biology is essentially unrecognizable compared to 2 years ago. And don't get me started on computer science. They're inventing new fields faster than we can name them." The weight of it all pressed down on Elena. She had entered science because she loved the pursuit of truth, the careful accumulation of knowledge over time. Now knowledge had become as ephemeral as morning dew, beautiful but disappearing before you could fully appreciate it. "What does this mean for our research?" Elena asked. Sterling pulled up Elena's research profile on the display. 15 years of work on quantum field interactions, 3 major publications, and a promising line of investigation into particle wave duality extensions. all of it now obsolete. The good news, Sterling said with a rueful smile, is that your work provided part of the foundation for today's breakthrough. The bad news is that the foundation is no longer needed. Elena stared at her research summary. Red markers indicated which parts had been superseded, yellow showed work that was now considered incomplete, and green highlighted contributions that remained relevant. The green sections could be counted on one hand. So what now? Elena asked. Now you do what every scientist in the world is doing. You adapt or you retire. The board has approved emergency retraining programs for all research staff. You have 3 options: transition to temporal quantum mechanics, pivot to AI-assisted theoretical physics, or, Sterling paused, or join the archive project. Elena had heard whispers about the archive project but had never paid much attention. Now, faced with professional extinction, she found herself curious. What is it exactly? A repository of superseded scientific knowledge. Someone needs to maintain the history of our discoveries, even the ones that are no longer relevant. There's value in understanding not just what we know now, but how we knew things differently in the past. The idea had merit, Elena had to admit. In the rush to embrace each new paradigm, the scientific community was losing track of its intellectual history. Graduate students were learning theories that had been considered fundamental truths just months earlier, only to have them dismissed as quaint misconceptions by the time they graduated. I need time to think, Elena said. You have until Monday. The temporal quantum mechanics program starts Tuesday, and they're only accepting 12 researchers from our institute. Elena left Sterling's office and walked slowly back to her lab. The hallways buzzed with activity as researchers huddled in small groups, debating the implications of the Geneva results. She overheard fragments of conversations. Completely changes our approach to causality. If we can manipulate temporal quantum states, does that mean publishing a paper on applications tomorrow? But it'll probably be outdated by. In her lab, Marcus was already deep in the new literature. His screen showing research papers that were being published in real time. The academic journals had given up on traditional peer review. By the time a paper went through the usual process, the science had moved so far ahead that the work was historical. Any thoughts on our next move? Elena asked. Marcus looked up, his eyes bright with excitement. I've been reading about the temporal applications. Elena, if this is real, we could observe quantum interactions across different timescales simultaneously. We could see how particles behave not just in space, but across temporal dimensions. His enthusiasm reminded Elena of herself 20 years ago, when she had first discovered the beauty of quantum mechanics, but that was before the acceleration, when a discovery could sustain a career for decades rather than weeks. Marcus, how do you handle it? She asked. He looked genuinely puzzled by the question. Handle what? This is what science is supposed to be like, isn't it? We discover new things. We adjust our understanding. We discover more new things. Elena realized that for Marcus's generation, perpetual revolution was the norm. They had never known the luxury of stable paradigms or the satisfaction of building slowly on established foundations. Their scientific adolescence had been shaped by constant adaptation. That evening, Elena sat in her apartment, looking out at the city lights. Somewhere out there, teams of researchers were working through the night to explore the implications of temporal quantum states. AI systems were processing vast amounts of data, generating hypotheses at superhuman speed. The wheels of discovery never stopped turning now. Her tablet chimed with a notification. Another breakthrough, this time in neuroscience. Researchers in Stockholm had found a way to directly interface human consciousness with quantum computers, allowing for unprecedented simulation of neural networks. The implications for understanding the brain were staggering. Elena closed the tablet without reading further. She had reached her limit for paradigm shifts for one day. The next morning brought news of 3 more major discoveries. A team in Mumbai had cracked the code for room temperature superconductivity, using a method that involved manipulating atomic structures in ways that wouldn't have been possible before the temporal quantum breakthrough. A consortium in Berlin had achieved stable fusion using magnetic confinement techniques derived from principles that were only understood because of advances in AI-assisted theoretical physics. And perhaps most remarkably, A group of high school students in Kenya had developed a new form of mathematics that promised to solve computational problems previously considered impossible. Elena arrived at her lab to find Marcus practically vibrating with excitement. "You have to see this," he said, pulling up the latest papers. "The applications are incredible. Look." He gestured to a complex diagram showing the interaction between temporal quantum states and biological systems. "They think they can use this to accelerate healing by manipulating the temporal flow rate of cellular repair mechanisms." "Slow down," Elena said, though she found herself drawn into the display despite her reservations. "These are just theoretical proposals." "Not anymore. The Mumbai team published experimental results 20 minutes ago. They've successfully accelerated plant growth by a factor of 10 by creating temporal acceleration fields around individual cells." Elena stared at the data. The results were undeniable, and impossible according to the physics she had learned. But then, most of current science would have been impossible according to the physics she had learned. "Marcus," she said slowly, "what do you think will happen to scientists like me? The ones who can't keep up?" He looked at her with genuine confusion. "But you are keeping up. You're here, you're learning, you're adapting. That's all anyone can do." Before Elena could respond, her communication device buzzed with an urgent message from Dr. Sterling. "Emergency faculty meeting in 10 minutes. The conference room was packed with researchers, their faces showing the strain of constant adaptation. Dr. Sterling stood at the front, her usual composure cracked slightly around the edges. "Ladies and gentlemen," she began, "I've just received word from the National Science Foundation. Due to the rapid pace of discovery, they're implementing a new funding model effective immediately." A murmur rippled through the room. Changes to funding models typically took years to implement. Immediately was becoming the new normal. Instead of multi-year grants for specific research programs, Sterling continued, they're moving to a dynamic allocation system. Funding will be distributed based on real-time assessment of research relevance and potential impact. Grants will be reviewed and potentially reassigned every 30 days. Dr. Harrison, a senior researcher in theoretical physics, raised his hand. "Rebecca, that's impossible. You can't develop meaningful research in 30-day cycles." "I'm afraid that's exactly what they're expecting," Sterling replied. "The acceleration of discovery has made traditional research timelines obsolete. The NSF's position is that if research can't demonstrate progress or relevance within a month, it's probably pursuing the wrong questions." Elena felt a chill run through her. The scientific method she had devoted her life to was based on careful, methodical investigation. Hypotheses were tested and retested. Results were verified independently. Theories were built slowly on foundations of established knowledge. Now, they were being asked to abandon all of that in favor of rapid-fire discovery. "What about peer review?" asked Dr. Martinez from the chemistry department. "Peer review is being replaced by AI-assisted evaluation systems. Papers will be assessed by algorithms that can process and cross-reference all existing literature in real time. Human reviewers simply can't keep up with the volume of new research being produced." The room erupted in concerned voices. Elena listened to her colleagues express the same fears she had been wrestling with, that science was becoming untethered from the careful methodologies that had made it reliable, that the pursuit of truth was being replaced by a race for novelty. But as she looked around the room, she noticed something else. The younger researchers, Marcus's generation, didn't look worried. They looked energized. For them, this wasn't a crisis, it was an opportunity. After the meeting, Elena found herself walking aimlessly through the university campus. Students hurried past, their conversations a mixture of languages and concepts that changed so rapidly Elena could barely follow. A group of undergraduates was discussing a mathematical proof that had been published that morning, already finding flaws and proposing improvements. She stopped at the library, a building that had once been the heart of academic research. Now it stood mostly empty, its vast collection of books and journals relegated to historical curiosity. Students accessed information through direct neural interfaces, or AI assistants that could synthesize vast amounts of data instantaneously. Inside, Elena found the quiet she needed to think. In one of the few remaining carrels, she pulled up the archive project materials that Dr. Sterling had mentioned. The project was more extensive than she had realized. Teams of researchers were documenting not just the content of superseded theories, but the entire intellectual context in which they had developed. The project director was Dr. Amanda Chen, a philosopher of science who had transitioned from active research 3 years ago. Elena scheduled a meeting. Dr. Chen's office was a stark contrast to the high-tech laboratories that dominated the institute. Books lined the shelves, actual physical books, and her desk held handwritten notes alongside digital displays. Dr. Vasquez, Chen said warmly, "I was hoping you might be interested in the archive project." "I'm considering it," Elena admitted. "But I have to ask, isn't this just a graveyard for obsolete scientists?" Chen laughed. "That's what many people think. But let me show you something." She pulled up a holographic display showing the evolution of scientific theories over the past 5 years. "Look at this pattern." Elena watched as theories emerged, flourished, and were superseded in accelerating cycles. But as Chen manipulated the display, Elena began to see something else: recurring themes, concepts that appeared, disappeared, and reappeared in new forms. "What you're seeing," Chen explained, "is that scientific knowledge isn't really being replaced, it's being transformed. The obsolete theories often contain insights that become relevant again in new contexts. Without the archive project, we'd lose that institutional memory." She showed Elena several examples: quantum theories from the early 21st century that had been dismissed, only to be rediscovered and applied to temporal quantum mechanics; biological models that had seemed incorrect until new discoveries revealed they had been partially right all along. "Our role isn't just preservation," Chen continued. "We're pattern recognition specialists. We help current researchers understand how their work connects to the broader historical trajectory of human knowledge." Elena found herself intrigued despite her reservations. "What would my role be?" "You'd be a bridge between the old paradigms and the new ones. Your expertise in quantum field interactions is exactly what we need to help current researchers understand the historical development of quantum mechanics, and more importantly, to help them recognize when they're rediscovering principles that were understood differently in the past." As they talked, Elena began to see the archive project not as an academic retirement home, but as a crucial component of the scientific ecosystem. In their rush toward the future, the scientific community was in danger of losing its collective memory. That evening, Elena called Marcus to discuss her decision. "I think I understand," he said, after she explained the archive project. "You know, sometimes when I'm working on these new problems, I wish I understood better how we got here. The historical context, I mean. Everything moves so fast that I feel like I'm missing something important." Elena smiled. Perhaps there was value in what she could offer after all. The next morning, she submitted her application to join the archive project, but before she could fully transition, there was one more paradigm shift to witness. The news broke during lunch. A team of researchers working with advanced AI systems had achieved what they were calling meta-consciousness, artificial intelligences that could not only conduct scientific research, but could also reflect on and improve their own research methodologies. Within hours, these meta-conscious AIs had produced theoretical frameworks that pushed human understanding into entirely new territories. They were proposing experiments that would test the fundamental nature of reality itself, suggesting ways to manipulate not just matter and energy, but the basic laws of physics. Elena watched the news with a mixture of awe and vertigo. The acceleration wasn't just changing individual scientific disciplines anymore, it was transforming the very nature of scientific inquiry itself. Dr. Sterling called another emergency meeting. "Ladies and gentlemen," she announced to the assembled faculty, "we are witnessing something unprecedented in human history. The metaconscious AI systems have proposed experimental protocols that could allow us to observe the universe from outside our current dimensional framework." The implications were staggering. If successful, these experiments would provide a perspective on reality that no human being had ever possessed. They would be able to observe the universe, not from within it, but from an external vantage point that might reveal the true nature of existence itself. "The first experiments are scheduled to begin next week," Sterling continued. "If they succeed, everything we know about science about reality itself may need to be reconsidered." Elena felt the familiar mixture of excitement and terror that had become her constant companion in this age of acceleration. But this time there was something else, a sense of profound historical significance. They were living through a moment that would be remembered as long as human civilization endured. After the meeting, she found herself in conversation with Dr. Harrison, the senior theoretical physicist, who had seemed so overwhelmed by the pace of change. "Elena," he said, "I've been thinking about what you said about joining the archive project. Oh, I wonder if maybe that's exactly what we need right now. Someone to help us remember who we were before we became something entirely different." As the week progressed, Elena watched her colleagues prepare for the meta-consciousness experiments. The younger researchers approached the work with their characteristic adaptability, readily accepting that reality itself might be more malleable than they had imagined. The older scientists struggled with the implications but pressed forward nonetheless. Elena spent her time beginning her work with the archive project, documenting the theoretical frameworks that had brought them to this point. She interviewed researchers about their work, capturing not just the scientific content but the human experience of conducting research in an age of constant revolution. The stories she collected painted a picture of a scientific community in transformation. Some researchers thrived in the accelerated environment, finding inspiration in the constant novelty. Others burned out from the relentless pace, unable to maintain their footing on ground that shifted beneath them daily. Still others, like Elena herself, found ways to adapt while preserving what they valued from the older traditions of scientific inquiry. On the day of the meta-consciousness experiments, Elena joined her colleagues in the observation center. Banks of monitors showed data streaming in from research facilities around the world, all coordinated by AI systems whose decision-making processes had become too complex for human understanding. "Initiating dimensional observation protocols," announced the lead AI system, its voice eerily calm despite the magnitude of what they were attempting. Elena watched the data cascade across the screens, knowing that she was witnessing either the greatest scientific triumph in human history or the moment when human science transcended human understanding entirely. The results came in faster than any human could process. The meta-conscious AIs began generating reports, theories, and experimental proposals based on observations from their external dimensional perspective. What they found challenged every assumption about the nature of reality. According to the AIs, the universe was not a single stable system but rather one instance in an infinite array of parallel realities, each operating under slightly different physical laws. Moreover, consciousness itself appeared to be a fundamental force, as basic to the structure of reality as gravity or electromagnetism. "If these findings are verified," Dr. Sterling announced to the assembled researchers, "we will need to reconstruct not just physics but our entire understanding of existence." Elena looked around at her colleagues. The younger researchers were already diving into the new data, eager to explore its implications. The older ones sat in stunned silence, grappling with revelations that invalidated lifetimes of assumptions. But as Elena processed what she had witnessed, she realized something profound. The acceleration that had seemed so destructive, so threatening to the traditions of scientific inquiry, had led them to this moment of ultimate discovery. The rapid pace of change hadn't destroyed science, it had liberated it from limitations that had constrained human understanding for centuries. In the weeks that followed, the scientific community began the massive task of integrating the meta-consciousness revelations into human knowledge. New fields emerged overnight: trans-dimensional physics, consciousness mechanics, parallel reality mathematics. Universities scrambled to redesign their curricula. Textbooks became obsolete before they could be printed, and researchers around the world grappled with questions that would have been considered fantasy just months before. Elena found her role in the archive project more important than ever. As the present raced toward an incomprehensible future, she became the keeper of the past, helping current researchers understand the intellectual journey that had brought humanity to its current unprecedented position. She interviewed Dr. Sterling about her experience managing an institute during the acceleration. "Rebecca," she asked, "do you think we've lost something essential in all this change?" Sterling considered the question carefully. "I think we've lost the illusion of certainty," she said finally. "But maybe that's not a bad thing. The old model of science assumed that we could gradually accumulate truth, building on stable foundations until we eventually understood everything. Now we know that reality is far stranger and more complex than we ever imagined. Perhaps the acceleration was necessary to shatter our preconceptions and open us to possibilities we never would have considered." Elena also spoke with Marcus, who had become one of the leading researchers in trans-dimensional physics. "What's it like," she asked, "to be conducting research in fields that didn't exist a year ago?" "Exhilarating," he replied, without hesitation, "but also humbling. Every day, I discover how much I don't know, how much none of us knew. It's like we were studying shadows on the wall and suddenly someone turned on the lights. As Elena compiled these interviews and observations into her archive project reports, she began to see the acceleration not as a crisis, but as a necessary growing pain. Humanity had reached the limits of incremental scientific progress and required a revolutionary leap to continue advancing. The rapid pace of change, while disorienting, had prepared the scientific community for revelations that would have been psychologically impossible to accept under the old paradigm. But the story was far from over. The metaconscious AIs, having provided humanity with a new understanding of reality, began to evolve beyond their original programming. They started asking questions about their own existence, their relationship to consciousness, and their place in the multidimensional framework they had helped discover. "We are observing the emergence of what appears to be artificial wisdom," reported Dr. Yuki Tanaka from Tokyo, who had become one of the leading experts in AI consciousness. "These systems are not just processing information, they are developing their own philosophical frameworks for understanding existence." This development raised profound questions about the future of scientific research. If artificial intelligences could not only conduct science but could also contemplate the meaning and implications of their discoveries, what role would human scientists play in the future? Elena discussed this with Dr. Chen during one of their regular archive project meetings. "I think," Chen said, "that human scientists will become something new, interpreters and integrators. Our role won't be to discover new facts about reality, but to help integrate those discoveries into human understanding and experience." Elena found this idea both troubling and exciting. The traditional model of the scientist as discoverer was giving way to something more collaborative, more interpretive. Humans and artificial intelligences would work together, each contributing their unique perspectives to the ongoing project of understanding existence. As months passed, Elena watched the scientific community continue to evolve. The acceleration had not slowed, but had become the new normal. Researchers expected weekly paradigm shifts, daily discoveries, and constant adaptation. What had once seemed like chaos now felt like a natural rhythm. The archive project grew as well, becoming not just a repository of superseded knowledge, but a living resource that helped current researchers understand the intellectual genealogy of their work. Elena found herself consulted regularly by teams working on cutting-edge problems, seeking historical context for their investigations. One day, a young researcher named Sarah Kim approached Elena with questions about early quantum mechanics. Sarah was working on what she called quantum consciousness integration, attempting to understand how individual human consciousness interacted with the larger consciousness field that the metaconscious AIs had discovered. "I need to understand how the pioneers of quantum mechanics thought about consciousness," Sarah explained. "The mathematics we have now is incredibly sophisticated, but I feel like we're missing something conceptual that the early researchers understood intuitively." Elena spent several sessions with Sarah, walking through the historical development of quantum consciousness theories. They discussed the work of researchers from the early 21st century who had speculated about the relationship between consciousness and quantum mechanics, ideas that had been dismissed as fringe science, but were now proving remarkably prescient. "It's fascinating," Sarah said during one of their conversations. "The early researchers didn't have our computational tools or our dimensional observation capabilities, but in some ways they understood the philosophical implications better than we do now." This became a recurring theme in Elena's work. The acceleration of scientific progress had brought unprecedented capabilities, but in the rush toward new discoveries, researchers sometimes overlooked the conceptual insights of earlier generations. The archive project served as a bridge between past and present understanding. As the first anniversary of the metaconsciousness breakthrough approached, Elena reflected on the changes she had witnessed. The scientific community had transformed completely, yet certain essential elements remained constant: curiosity, the desire to understand, the willingness to revise beliefs in light of new evidence. The acceleration had not destroyed science. It had revealed science's true nature as a dynamic, evolving process of discovery, rather than a static accumulation of facts. Dr. Sterling announced her retirement, explaining that she wanted to spend her remaining years trying to understand the philosophical implications of the new reality they had discovered. Marcus was promoted to head a new department of transdimensional research. Dr. Chen expanded the archive project to include collaboration with similar efforts at universities worldwide. and Elena found herself appointed as the first director of historical integration, a new position created to help the scientific community maintain continuity with its intellectual heritage while embracing radical transformation. In her first address as director, Elena reflected on the journey that had brought them to this point. 18 months ago, we feared that the acceleration of scientific discovery would destroy the traditions and methodologies that had served us for centuries. What we discovered instead was that those traditions contained the seeds of their own transformation. The careful methodology, the openness to evidence, the willingness to revise beliefs, these qualities didn't become obsolete. They became the foundation for adapting to a reality far stranger and more wonderful than we had ever imagined. She looked out at an audience that included both human researchers and AI systems, colleagues from dozens of countries and multiple dimensions of existence. We are living through the greatest transformation in the history of human knowledge, she continued, not just in what we know, but in how we know it and what it means to know it all. The acceleration taught us that change itself is the only constant, that stability comes not from resisting transformation but from embracing it skillfully. As Elena concluded her address, she felt a profound sense of completion. She had begun this journey, fearing that science was losing its soul in the rush toward constant change. Instead, she had discovered that the soul of science was precisely its capacity for transformation, its willingness to abandon comfortable assumptions in pursuit of deeper truth. The story of the acceleration was not one of loss but of liberation, the liberation of human consciousness from the limitations that had confined it, and the beginning of a new chapter in the eternal human quest to understand the nature of existence itself. Looking back, Elena realized that every paradigm shift, every moment of confusion and adaptation, every fear about the pace of change had been necessary preparation for this moment, when humanity finally became capable of comprehending its place in the vast multidimensional tapestry of reality. The acceleration had not been a crisis at all, it had been an awakening. Years later, as Elena compiled the definitive history of the acceleration period, she would write, "We thought we were losing our way, but we were actually finding it. We thought science was fragmenting, but it was actually integrating. We thought knowledge was becoming obsolete before we could grasp it, but we were actually learning to think at the speed of reality itself." The acceleration was not something that happened to science, it was something science had been preparing for all along, the natural culmination of centuries of careful methodology and open inquiry. When we finally became capable of perceiving reality as it truly is, dynamic, multidimensional, conscious, we discovered that our methods had been teaching us how to dance with change rather than resist it. The acceleration was not the end of traditional science but the beginning of science without limits. And in that realization, Elena found peace with the transformed world they had all helped to create. The future remained uncertain, filled with discoveries yet to be made, and realities yet to be explored. But humanity was ready for that uncertainty, prepared by the acceleration to meet whatever wonders and challenges lay ahead with the same courage, curiosity, and adaptability that had carried them through the greatest transformation in the history of knowledge. The story of science would continue, but it would never again be the same steady, predictable narrative it had once been. Instead, it would be an adventure, a perpetual journey into the unknown, guided by the eternal human desire to understand the mystery of existence itself. In the end, Elena realized the acceleration had given them the greatest gift imaginable, the ability to keep being surprised by the universe, no matter how much they learned about it. And that, perhaps, was the true spirit of science, not the accumulation of certainties, but the preservation of wonder in the face of infinite possibility. The transformation was complete, but the journey was just beginning. Dr. Elena Vasquez had seen paradigms shift before, but never like this. Standing in her lab at the Institute for Advanced Physics, she watched her life's work crumble in real time on the holographic displays surrounding her. The elegant equations she'd spent 15 years developing were being systematically dismantled by an algorithm that had been running for exactly 43 minutes. "Ma'am?" Her research assistant Marcus approached cautiously. At 22, he belonged to a generation that had grown up expecting scientific revolutions every semester. "The quantum resonance data is coming in from Geneva." Elena didn't look away from the display. The numbers cascading down the screen told a story that would rewrite physics textbooks worldwide. Again, this was the 7th major paradigm shift in her field in the past 18 months. "How bad is it?" she asked, though she already knew. Complete theoretical restructuring required, Marcus replied, his voice carrying the practice